Hello and welcome to day 3 of IoT Design Week. Today is Security Day. My name is Rachel Bedore and I am joined today by Xavier Bignale. Xavier is the Program Manager for our Secure Products Group. How are you doing today?
Good, Rachel. Thanks for having us today.
Yeah, and on Skype we have Quinn Tran. She is a Program Manager from Microsoft Azure. How are you doing, Quinn?
Hello, everyone. I'm doing good, and thank you very much for having me here today.
Yep, it's good to have you. I'm really excited about this. So we have a couple free development boards, and I'll take you back to the booth for them to tell you a little bit more about that.
Of course. Good morning.
Good morning.
How you doing, Wayne?
You know what? I'm hyper right now.
You're excited for day 3?
I'm excited. We have 113 up in the in the chat right now.
That's a lot, yeah.
Yeah, absolutely. So thank you guys for joining us again. I'm Wayne Freeman.
Clifford Swartz.
And we're going to be your kind of behind-the-scenes the elves, if you will. So thank you, Quinn, for joining us from Microsoft. Thank you, Xavier, for joining us from our security group. Thank you, Rachel, once again for being our gracious and humble host. And so basically, we're going to go over how the giveaways work.
Right.
We're going to give you things, but you have to fill out a survey. And I understand. So we've gotten a couple of people who have emailed us and have said, hey, we really don't like the fact that we have to fill out a survey really quickly. So don't worry about that. We'll do another survey at the end with a little bit less time pressure. But for the purpose of providing the giveaways for today, we're going to drop a link to the survey in the comments.
Yep.
And the first, Rachel, how many? 5 are we doing?
10.
First 10. Wow, this is going to be a pretty big one today. The first 10 people who respond to that survey, who fill it out, we'll contact you. We'll get your information, and we'll get you out a
Trust platform development
trust
kit.
platform. Yes.
Yeah. So in addition to all of this, we will also be shifting through the comments and trying to deliver them onto the stage as best we can. But if we can't get to your comment, or if there's a question that you were just dying to know the answer to, make sure to email us at livestream@microchip.com, and we'll do our best to pass that along to the appropriate parties.
Absolutely.
Yeah. But excited to be here. Thank you very much.
Yeah. Back to you guys.
Just one more housekeeping thing. If you are worried about the survey, kind of a backdoor way to get a free development kit, we've been posting on AVR Freaks. So if you write a haiku and you post it on AVR Freaks, that haiku has to be about IoT security. If you show my screen, we already have a couple. We'll send you a free development board. So that's until 10:15 a.m. or until supplies run out. So
Until 10:15 or supply. So by the way, that's an hour and 12 minutes from now.
Yep.
For those of you who are not sitting in Pacific time.
So that's a lot of time. So we expect high quality haikus for sure. All right, well, let's get started. So today we're going to be talking about security. Xavier, can you give me kind of a snapshot about what embedded security is and what you're going to talk about today?
Yeah, actually, I'm going to go a tiny bit off script. If you can switch to my screen here, and I'll show you what we do in terms of security. Can you switch to my screen on the laptop? I'm going to project that. There you go. So if you go to microchip.com/shields-up, you'll basically land on this page here. So it's a webinar series that Microchip is providing today, where all the business units are getting together and we talk about security from a feature standpoint and how to implement or leverage a feature. It's a 30-minute webinar series that we are doing every 2 weeks. So I'm actually going to use the Shields Up #2 series here and go full screen. So we already have recorded that. So if you want to go back to it and listen to it later, it's right there. And that's kind of how we describe embedded security here at Microchip. So it's kind of a layer cake where we talk about the first layer at the very bottom, start from the bottom and go up. We talk about the hardware without trust. The hardware without trust, what it is, it's 2 things. You have a private key basically that will be used for the device to cloud authentication, and you want to protect that. So you want that key to be unique, protected, isolated, and managed, right? The second thing you want on the hardware without trust is to do a secure boot. You want to start from a genuine code that your system can trust and boot from. The 3 layers up, so counterfeit protection is really something that deals with cartridge authentication, disposable authentication, peripheral authentication to protect the counterfeiting of those peripherals. IP protection, secure update, the philosophy is pretty simple. You sign a code that you will update or that you will verify. You verify it during runtime for IP protection. You verify it after an update, an over-the-air update, for example, in the world of IoT. So you verify that code after the update. To do that, you obviously have to push a code through a network, and that's where you want to ensure your secure connectivity. Secure connectivity, you're in the world of communication. So the guidelines is use standard protocol like Wi-Fi and Bluetooth and Zigbee's, LoRa. Those are well-defined standard, and standard means you can test them. Standard means also they're being pen tested themselves very, very recurrently, and bugs are being found, which is healthy because they're getting fixed. And that's so your standard communication protocol is more and more robust. The last layer at the very top here is application layer security, and that's kind of a bridge towards the software industry and the cloud industry. Application layer security, if we dumb it down to a very simple term, it's you control the elevation of privilege. So meaning you have a login, a password. I'm simplifying that. It can become much more complex real quick. But you have a login and a password that can allow you to access to a zone of your system. Now you can talk about trusted execution environments, privileged access to those privileged zones, right? For example, that's what it is. Above that, obviously, you have the world of software service and cloud services, and that's where you also need to have those components in your security architecture and security strategy. And that's where we draw the line from a semiconductor provider. And there, I'd like to ask Quinn, who's on Skype with us, what does it mean to you, security, secure authentication? What does it mean to Microsoft IoT?
Yeah, Xavier. Security or safely authenticate an IoT device to Microsoft is very, very important because that's how the initial trust between the device and the cloud is established for later business flow. So we put a strong emphasis on that.
Great. So throughout this live stream, we're going to use an examples that we can kind of come back to bring all our discussion into real life. So earlier we asked you guys if you could come up with any examples, and somebody said smart mailbox. So I really like that. So for the next question, if you guys could just answer it and then kind of go into how that would affect something like a smart mailbox. So I was just wondering kind of what are the challenges today when we use and implement secure authentication?
Okay, so for the embedded side, there's a couple of things. If you talk about the process of developing an IoT product, for example, you need to go through prototyping, your development phase, and go to production at scale, right? So those are three very important factors. So the first one is how you get started in security. It's extremely difficult because here's the other notion in security, it's going to end up to be custom. Because now you deal with that unique key into every system, and now I'm down to keys and re-authentication. I'm ignoring the layers above that have their own layer of enablement and production challenges. The paradox is you have the IoT market that is fragmented across the globe, right? And you have security that demands customization. That's your paradox. Mass market, customization. That's your paradox right there. So how do we address that? We'll cover that later on. So what does it mean from a customer standpoint? When we talk to all the customers across the globe, the problem is pretty obvious. How do you place that unique key into the smart mailbox, for example? The smart mailbox, take the city of Phoenix. We got Phoenix and all the agglomeration. We got 5.5 million people. Count the number of mailboxes. How do you place that unique key? Imagine all the smart mailboxes in Phoenix. How do you do that? Do you place it one by one? It's not financially scalable. You can't place. So now you have to go through a contract manufacturer that will do that, right? So the contract manufacturer, what is he going to receive from who? Who's receiving the key from? That's number one problem. Who's going to issue the key? That's another problem. How much is that going to cost? That's another problem. And then now he's got those, let's say 5.5, let's be idealistic, and the whole Phoenix is equipped with smart mailbox. You got 5.5 million mailbox that you're going to have to drop keys into. How do you do that? So the CM is going to be dropped with 5.5 million keys, and it's going to have to individually place them into the mailbox. That's test time. That is cost. And it's not just cost because of test time. It's cost because He's going to have to talk with the product company that's going to sell the smart company. He's going to have to talk to the certificate authority or wherever the source is and negotiate contracts and handle secret exchange and all that stuff. Now imagine the smart mailbox company wants to change the CM because they are too expensive. They are not producing fast enough. All the keys are at the CM now. What do you do with it? Those are the problems that we see in IoT. Again, and that's I'm talking about production. Now you got the enablement, the prototyping. How do you even get started with this whole thing of keys before even you talk to your CM, right? So you need tools, you need knowledge, you need training and stuff like that. And so it's been hard for the past few years. You look back at the IT industry, and Quinn can probably correlate with that. You go back 20 plus years ago at the beginning of the internet, that was the same problem. So it's just the problem that the IT industry went through from starting, developing, producing, managing, enabling, we're having them in IoT security today.
Okay, so it sounds like challenges throughout the entire process.
Pretty much, yeah.
Quinn, from the Microsoft Azure side, can you speak a little bit about the challenges that people might face?
Yeah, of course. Xavier, good point that you pointing it out earlier. I'm with you on those challenges. And from the cloud perspective, when we look at secure authentications, we not only looking at the initial cloud connections, but we also have to make sure that look into the whole device life cycle of planning, provisioning, configuring, monitoring, and retiring the device. So the real question to ask is how can we securely authenticate our device to last through that whole device life cycle? And what is the combinations of hardware and cloud that can help ease in the process of securely authenticate your device? And so that is my take on that.
Okay. Oh, do we have a question?
Yes, we do.
Actually, I could just like making meow noises into your ear. By the way, for those of you who don't know, that's how we signal the folks on the stage as to whether we have a question or not.
Yeah.
There's a question from Craig Potter for Xavier. It says a lot of your TPM and dev kits are based around Wi-Fi transport. Can the solutions easily be used for cellular IP for HTTPS applications?
Yep, yeah, that's actually an excellent question. So what we see in the their movement in the cellular industry, that could be a whole live stream in its own. So what we've learned from the cellular industry, the telco industry, what you have a SIM card already, right? So your SIM card is going to be generally in your gateway, and you can argue eSIMs are coming up, but are they being used across the billions of units? And forget the mobile world, right? For a minute, think about real IoT device, very confined devices. So what those SIM cards are doing, they're authenticating your telco. And that's what it is. Behind the telco, what you have is your cloud backend. That's where your Microsoft will be sitting. So you got Microsoft, telco, your network, gateway, and the edge node, right? So the SIM card will likely be in your gateway, maybe on some of the IoT node, but they only authenticate the telco so far today, and that might change, right? So then the value of adding that secure element, I want to make sure when you use secure element, we differentiate that from TPM, even philosophically it's the same thing. A TPM is Trusted Platform Module for the sake of definition, and that's where Microchip comes from, right? 20 years ago. There's an amalgam being done by the tech community of confusing TPM and secure element. That can be, again, another debate in itself, but let's call secure element. So the secure element will have the key to authenticate the cloud. The SIM card will have the key to authenticate the telco. From a security purist standpoint, you would need to do both, basically, right? So your question about HTTPS, there is an elegant way to do that. It's through the PPP transport protocol. We don't have code. We have partners that have codes today, such as working, for example, with Wolf SSL and Oryx. I think it's, I can't remember, the Cyclone SSL. They have those integrated into their TLS protocols. So that's how you would go at it.
Oh, that's a good question. Any other questions in the booth? Or?
No, you guys can continue.
Okay, so we just went over a little bit about the challenges people face when they're creating a secure IoT product, and then also managing and deploying it and retiring it on the cloud side. So why don't we go over kind of for Xavier, what Microchip does to help people navigate those challenges?
Okay. So what we've done at Microchip, we remember I mentioned the problem of cost of getting a certificate chain, the difficulty to even know who provide that, and then when you get there, it's pretty expensive, honestly. And now you're in the world of certificate. They're doing a great job, but it's not affordable by everyone. And again, I'm insisting on the fact that IoT is a very fragmented marketplace. So the cost for those offering is pretty steep for most of the IoT project, I'd say. An IoT project could look like, a startup. It could look like a small company, I don't know, let's call it a $50 million revenue, $100 million revenue, or even into large companies that are trying to develop a first prototype to expand into the world of connected devices. So when you have a prototype product to try your strategy into the connected world, the funding is not going to be, you're not going to have billions of dollars funding. So, and then when you come in and you have a 6-digit fee just to get a certificate authority, it kills your project. And we've seen companies tripping over and over and over by that. And then you get back to how you get started on top of having that financial problem. So what we've done, if we switch to my screen again, let me get the right page here. So what we've done at Microchip, we've launched the Trust platform. So what it is, it's not a TPM, it's a program. And what it is, it's composed of 3-tier offering, which is composed of Trust and Go, Trust Flex, and Trust Custom. So Trust and Go here, it's basically a black box secure element that is pre-configured and pre-provisioned with default certificates and keys, with our generic certificate and keys. So once you buy it, you don't have to talk to a certificate authority. You also get the certificate and the private key already in the device. You can buy that directly from our e-commerce store, microchip.com/purchase, or any participating distributor in the marketplace. So what this Trust and Go does, it does two things basically. It does TLS network authentication, or it does LoRa network authentication. We have two different part numbers for that. The second one is Trust Flex. So now we're in that world where actually company can afford a certificate authority and want to do more than just network authentication. So you get into the Trust Flex. So we keep the generic certificates and keys in there. We can override them and lock obviously the device using a provisioning service. If you want to do it yourself, you can. We don't necessarily recommend that. So you can do device to cloud authentication and a few other use cases like token-based authentication, still in the world of authentication. You can do anything, firmware verification, so after secure boot, during runtime, after an OTA. You can do IP protection, message encryption, IO protection, key exterior authentication, key rotation. The device can do key rotation. That's built in itself, meaning your certificate infrastructure and your whole network is going to have to be architected accordingly, much more difficult. Last point, Trust Custom is basically a fully customizable secure element. So we give choices to be able to enable the customer to scale their business, no matter if they have a financial hurdle to start the product. Okay, I will. And yeah, that's basically what we offer.
So for somebody who is starting out making a prototype for a smart mailbox, it sounds like Trust and Go would be the first way to start, or?
It really depends. It really depends how financially equipped this company is, or how mature they are in the world of security. And those are two different things. Can they pay a CA to manage the entire certification? It's probably the cleanest way, right? We got large company doing that. If they can't and they're starting to, maybe Trust and Go is probably the best way to start. And they can evolve from Go to Flex to Custom pretty smoothly too.
Okay, that's a good overview, thank you. So Quinn, from the Microsoft Azure side, how are you guys helping customers navigate the complexity and challenges of secure IoT design?
Yeah. So Xavier, having your device identity being secure in a secure element is definitely a good first step for secure authentications. And to answer racial questions, can you help me pull out slide number 2 on my deck? All right. Yeah. So to help solve the challenges of security IoT, Microsoft offer a comprehensive and diversified portfolio in which you can see that is offered for different verticals like manufacturing, retail, agriculture, and so on. And I want to highlight like the PaaS and the SaaS service that we offer, such as the IoT Central and IoT Hub, that can help the customer to quickly connect the device. And another services I want to highlight as well as the Azure IoT Hub device provisioning service. That is something that I will touch in details later, but that is a service that can help customer to register or connect your device to cloud as scaled.
Great. And when you say IoT Hub, what does that mean? I like the name a lot.
Thanks, Rachel. So IoT Hub is a PaaS offering, PaaS in the sense of platform as a services, and it's a platform that allowed the secure bidirectional communications between your clouds and the devices. And on top of that is offer a device management to help you manage your device as scaled and many more features. And I include a link later at the end of the talk for you to explore more on IoT Hub. And Rachel, can you pull out slide number 3 real quick? Yes, and so this is just a quick look of what is IoT Hub look like. Is a portal that you can go create an account and register the information and start to connect your device and manage the device on the website. And that's about it. Back to you, Rachel.
Great. So just to recap, so far we've talked about the challenges, both from the embedded side and from the cloud side throughout the entire device lifecycle, from prototyping and designing, deployment, to managing and retirement of devices, and how Microchip and Microsoft both have tools for you guys to navigate those challenges and make it a little easier for you, and get that smart mailbox out into production fast. So Xavier, I know you had brought the giveaway that we're giving away today. Do you want to talk a little bit about what that looks like to work with that?
Yeah, definitely. So we'll try to demo something. So that's the little giveaway here. What you have here, you have a SAMD21 microcontroller. It's a Cortex M0. Why do we choose the Cortex M0? That's kind of the reality of IoT that we see in the market. It's a very cost-efficient, simple to use device and it's so simple that people are going to it pretty easily. So that's why we choose this micro. On top of it, you have the Trust and Go, Trust Flex, and Trust Custom devices right there. You have a micro bus footprint to plug into a Wi-Fi, or if you want to plug more Trust platform secure elements on top of it, you can do that and stack the Wi-Fi on top. So that's why we also have a debugger, and that's what I'm going to use today. I think we have questions I've heard.
Yes. Is there a question in the booth?
Yes, there is. So this one comes from Alfredo, and he says, how should one deal with changing secure keys over the air?
That's a.
Thought you'd like that one.
Yeah, no, that's a good one. Don't do it. Plain and simple. I'm saying don't do it from, again, being a security product manager, I will tell you don't do it. If you don't use secure element, you likely have your key into the flash of your microcontroller, which is not the most robust stuff, the most robust architecture. In that case, yeah, you're going to need to do that. It's far from being one of the recommended practices. Avoid it. If you restrain to it because you don't have secure key storage on your system, you will be at risk. There's no matter if you change your key over the air or whatnot, it's not that. That's why it's not, again, because I own this portfolio, it's what you want to do. Here's the analogy I can give you as a proven, robust, and used architecture. TPM come from the server and the computing industry. All servers and laptops, desktop have a TPM. TPM is what separates the key physically from the rest of the system. So they do that. The phone industry uses the SIM card. The payment industry uses the smart cards. All of that are secure key storage, isolated from the rest of the system. Why don't we learn from those industries that are, just payment is what, 30 plus something years, maybe more. So to your key, if you're obliged to do that because you have a key storage, you're going to have a key hopefully encrypted over a TLS that's an encrypted COM, and it's going to land on your micro, and here's your key. that's going to be your vulnerability. But how you change that, it's going to be challenging. That's where you might want to work with the certificate authority companies, but that key, that's the root for everything, is going to be exposed. So just be conscious of that.
All right.
Cool, and I actually have one more while we're at it. So this one is from Sahid, and he asks, what about sub-1 gigahertz networks and radio microcontrollers targeted towards low-resolution data? Would it not be overloaded with encryption and decryption?
No, not necessarily. So let's take the example of sub-gig. Let's take LoRa, for example. LoRa, and you're right. You basically don't use PKI over a sub-gig radio. The latency is not going to cut it. It can't handle, the RSA or the ECC crypto algorithm. So you're absolutely right there. But those networks only, so for example, the example of LoRa, they use AES 128s, and they use shared key architecture. So, and we've worked actually with the things industry and Actility and with more companies of the LoRa industry to implement a pre-provisioned secure element where we have a shared key into the secure element. They have the symmetric keys on their joint servers. The joint server is a new concept there that's kicking in. And basically the authentication happened between those shared key that are pre-provisioned and the joint server and the secure element. So there are ways to handle that.
I actually think we're working on something that will enable you to add robust security to those networks. So keep an eye out, keep following us and stuff.
All right, are we good with the questions?
Yes, sir.
All right, let me try out the demo then. So back to this little board, what you'll need to run this demo is a separate board here that it won't be part of the giveaway because it comes from a third-party company called Microelectronica. So if you go to microe.com, you'll be able to get the Wi-Fi, and I'll show you where to get the exact hardware there. So to avoid any trouble in the demo, I've pre-programmed everything already. But if we want to switch to my desktop, there you go. I'm going to show you where you get started and all that. So for the Microsoft demo here, we go to microchip.com, microchip.com/trustflex Azure. And once you do that, you'll land on this page here. Tells you all the use case you can do with the TrustFlex. You can do. So far, what we've implemented today is just the custom certificate authentication. The first thing you want to do is install the Trust Platform Design Suite software. So we click there, and it basically leads you to a user manual on how to install the software. Make sure you have the prerequisites in place. So use the latest version of Windows, use MPLab, the right version, and you start downloading your installer. So I've done that actually just before this live stream. Follow the installation, make sure you follow the path too, and then we tell you how to upgrade, update to the latest version. So make sure you follow this. Once you have that, now what you have on your laptop is something called Anaconda here. So when you open up the Anaconda folder from your menu, you're going to see Anaconda Navigator, Jupyter Notebook. So Jupyter is part of the Anaconda environment. And what it helps us to do is to run Python executable command to set you up with a secure element for prototyping only. Don't do that for production. We get you taken care of with a Microchip provisioning service for that. And also help you to set up with the Microsoft Azure environment. And I'm going to go through that in a minute. So the other thing you want to do is go to Start Here. If you look for Start Here, basically what it'll do, let's see if it works. No, that's live. It should guide you to an HTML page. I've had a network problem, so I don't know if, no, it doesn't work here. So I've had a network problem. It guides you to a tutorial where it'll guide you through the entire onboarding. So let's go and start. So the first thing we'll want to do, like I said, go to Anaconda, open my Jupyter Notebook here. And what it will launch is actually an HTML page, as you're seeing here. If I follow the installation path, I have to go to the Trust Platform folder, Design Tools, and now I've got all my selection of TrustFlex, Trust and Go. An important place to know about is the doc folder. You have all the PDFs of all the use cases that the tool is offering, and that we're going to grow this environment, obviously. And another important piece is this little CVS file, Azure IoT Hub credentials. We'll have to see. I'll show you in a minute why it's important. So where we want to go is back to my design tool. On the asset folder, there's one important piece that Factory X program is the first thing I'm going to have to take care of. So let's go into it. To go to it, I'm going to open up MPLab. And I've already opened up the project. So I went to the right folder, opened up the project, and I built it already. So I'm not going to do that here. You need this piece of firmware in your micro to start, to execute the first notebooks. If not, it's not going to work. So make sure you have that program into your microcontrollers. You just make the program, and it programs the microcontroller. To save time, I've already done it. It takes a minute or two to program. The second thing you want to do, I'm going to go to my folders here, architecture, under, so where did I place that? I think I have to go back to, and you can see the path here. Under user, it's me as a user. I'm going to go to Trust Platform, Design Tools. And as said, we need to take care of the Microsoft credentials, which are located in Docs. So I'm opening the Azure IoT details here, and you'll see what the Excel spreadsheet looks like. I have to place something called IoT Hub and subscription ID. Where I'm going to get that is from my Microsoft portal. So if you do portal.azure.com, you create your accounts, put your credit card in, and that's basically what you have. What you have to do to get there is create a resource, look for IoT Hub, and it's that easy with Microsoft. And then you can start playing with their IoT products. I've already created that, again, for the sake of time. In the PDF file, everything is described line by line, and make sure you read the manual very attentively. Don't take shortcut. It costed me a few hours with our technical team because I didn't read correctly. If I go to my hub, here's my host name that I'm going to need, and the IoT Hub name is just those, whatever is before .azuredevice.net. That's what you want to copy into your CVS file. The second thing is the subscription ID. So you're going to copy those two fields in the file here. I'm not going to do it. Again, I've got the demo working for the end. And then you set up with your Microsoft Azure account for now. Now, what I'm going to do is now I can work with my Jupyter notebook. The first one I want to open up is I need to go to TrustFlex, which is and I want to generate resources. So if I go there, open this IPYNB, what it's doing, it's going to generate prototype chain certificates to help you to connect to Microsoft Azure. Okay, so I'm going to have a signer, device certs, and everything is done in that Python executable environment, which is Jupyter. And the only thing you really have to do is go to kernel, run all. Again, I've already run it, so it's done. And what will show up here, if I go back to my folder, so the TrustFlex, I believe it is, and resource generation, you can see here my the root, the signer, and something called the manifest here. I'll tell you what it's all about. If I want to stop at the provisioning and the secure element and be selfish, this is it. I'm done with the secure element. So I've configure the secure element. Well, we're providing you the configure secure element already, so you don't have to worry about that. We provisioned it, and we are ready to ship pretty much. So obviously, don't do that in production. We'll use the in-factory provisioning service to deliver you those devices. So now we're done with the secure element. What we want to do, if we go back to my display here, I'm going to close the resource generation. And now we want to give you a Microsoft Azure project that you can work at the C level. So I'm going back to my TrustFlex folder and look for the custom PKI Azure notebook. Going to notebook. As you can see here, there is a notebook folder and a C folder. As you can imagine, the C file is there, and notebook is in the other folder. So I'm launching this IPYNB, and the way it looks like, just like that, bunch of Python executable. And what it'll do, it'll basically, I'm not going to run it again. I want to make sure the demo works, and hopefully it will. When you run this executable, it will ask you to log into your portal. So you're going to click on that button at the end. That's going to show up here. It's going to turn green as you log in. The next step is going to register the signer of that chain of certificates that we created. Now the signer is going to be in my IoT Hub accounts. And because you've set up your credential correctly in your CVS file, it will get into your account and authenticate the account. And so all of that is taken care in the back of the scene. That's how we simplify literally months of development. We've seen customers, and it's not a data point, it's the vast majority of it. It could take up to 2 to 4 months to get up there, and now in a couple of minutes we have it. So we give you the PDF. I'm going to do a 30-minute webinar in a couple of weeks on just that, so the technical onboarding. You'll have that available if you want to go into every single step. We'll make that available to you. And at the end of the day, what you have is basically, now we'll see if it works. So I've run that. If you want to switch the camera back to me, we'll see if it works. So I've done that just before the live stream. So we see this little LED here is, I don't know if we see it, it's off. Just going to turn it on. So what's happening is I'm going to go to my portal. Can you switch back to my screen? And this is how you work with an IoT device. You scroll down there. I'm going to look at IoT devices, the device that I've registered. So this device ID here, it's basically the device ID that was given through the previous onboarding process. I'm going to send a message to the device. Let's see if it works. So my LED is off. I'm going to turn it back on. And if we want to switch the camera back to the board, see if I'm lying or not. And now the moment of truth. So the message has been sent and the LED is on. So it works.
Wow, it worked.
So we took a few shortcuts, granted, but again, the loading time, all that, we're going to cut that out. So this is what we're giving you. We're giving you the tools to provision, a pre-configured secure element, the Trust Flex. We give you the entire C code example to work with our microcontroller, the Wi-Fi, and the necessary code to push and receive MQTT message to Microsoft Azure IoT Cloud. So all of that is available through microchip.com/trustflexazure.
Okay, you mentioned the word manifest a couple times. Can you clarify? Can you just kind of explain to me what that is again?
Thanks for bringing that up. So a manifest is when, in the TrustFlex case, what happened is, let's say you're the customer, you want to use the TrustFlex device, and you have your own certificate. Let's call that the root certificate or the customer certificate. What's going to happen in the back of the scenes, I'm going to ship you a pre-configured element. You're going to use the tools, and you're going to be happy with the use case you've selected, and then you're going to start to exchange back to us. So now at this point, we need to do a secret exchange. So I'm going to send you a certificate sending request. You're going to sign it with your customer certificate, root certificate, whatever terminology you use. And that's going to get back to Microchip into our HSM. We do what we do in the backend, provision the elements, the secure element. And on top of that, what we do, we create in your e-commerce account, whether it's ours or the distribution, we create a JSON file that contains the list of device certificates, the public keys and the serial numbers of the device you placed into that order when you're in production. So that's how we share with you the public information of the device. We're certainly not going to share the private keys. They stay in the device and will stay there. Now, that's how we've delivered, let's say, I don't know, you place an order for 50,000 units, you're going to have 50,000 credentials for each of the devices you've ordered in that place order. Now, what you do with it is the next step of the discussion, and I think that's where we ask the question to Quinn here. So now, I've got secure elements, I've got this manifest, I've got 50,000 units. How Microsoft Azure helps with scaling that to production?
Yes. Sounds good, Xavier. So your question is, how can we take advantage of the manifest to help with the mass productions in the long run? Before I answer that question, I noticed that we've been mentioning this term a couple of times, the term provisioning, and I want to take this chance to clarify with the audience first. So I heard, audience, you probably heard Xavier use the term provisioning when he talked about his demo, and then I'm going to talk about device provisioning service. And I want to clarify that when Xavier, as a chip maker, talk about provisioning, he meant to inject the key or the secret into an IoT device. Rachel, could you help me pull out one of the slides that we worked together before? On that, so that it gives the visualizations. Yes. So this is the clarifications. In Microchip, term provisioning is between the key and the IoT device. However, from Microsoft, a provisioning service is the connection between the IoT device and IoT hub. So I just want to make clear this before I move on. Are we good on this?
Yes, thank you. And actually, I think we might have a question in the booth.
Maybe
So thanks
even
for that
2 questions.
clarification, Quinn. We'll get right back to that. But can we answer the question first? real
Ooh,
quick?
you counted 2, so I'm going to go ahead and let you.
Oh, okay. So number 1 we have from Krish Rao. How do you balance security features and energy efficiency on the edge devices?
That's a good one. Energy efficiency and security feature, that's basically your trade-off. So the way I would answer that is maybe by the Cypher suite you're selecting. We've had the discussion actually with my director yesterday. He was actually explaining that to, and it's one of the way I probably going to miss a few points, but you got a debate between RSA and ECC. What's good, good or best? They both have their advantages. If you're concerned by energy efficiency, and more than that, it's how much processing of your Cypher suite, and it's actually gave me another idea. So Cypher suite, let's say RSA ECC, and it's the time it takes to your microcontroller processor to compute something. That's how it sucks up energy, right? So there is another notion of software versus hardware-based crypto acceleration. Software will take much more time, and that's when you're using many more cycles, meaning you're sucking up more power. If you use hardware-based acceleration, which is the whole philosophy of using secure element that helps with the efficiency of your system, you're gonna get, I can't remember the ratio, it's like a ratio of 100, I think, between software and hardware acceleration, if I'm not mistaken. So we have the numbers if you're interested. I'm more than happy to share the comparison with you. Wolf SSL has actually done a very nice comparison of both. If you guys can remind me to follow up on the question, we'll send the documentation in the article that talks about it. So hardware versus software crypto acceleration is one, and the side of the Cypher suite. So Cypher suite meaning key length. The RSA key length are much bigger to achieve the same security bit length security as ECC. Meaning ECC will require less processing cycle, and your memory, the key length are smaller for ECC, your memory is slower, your power is going to be a bit more efficient on that. So that would be the answer. I don't know what else I could think about to answer that question, but yeah, that would be the start of my answer.
Oh, that was a great answer.
I think you did good.
Number
2.
Yeah, number 2. There's been some chatter in the YouTube chat, and I wanted to, and it actually Nicolas answered the question already, but I wanted to have this discussion with you for the benefit of the folks on LinkedIn Live.
If we answer the same thing.
Sure, but we got we have 3 platforms now, just advertising. So the question is around the data sheet for the Bayer ECC 608A. Mm-hmm. One of the commenters mentioned that it's not available, and the question was why. And we obviously have various versions of the ECC device. So if you could kind of elaborate there.
Yeah, absolutely. So it's been a common question asked. I've said the paradox in security and IoT, you got IoT fragmented market and security that demands customization. Customization means support, right? It's true for every provider in security into any industry. How much support do you invest into your security product that you're going to deliver to the market? So what we've done to solve that, I'm going back to the Trust platform, we still offer that fully customizable service through Trust Custom, and we will keep the data sheet under NDA. Why? Because what we've seen in the industry is, at the end of the day, what customers are using is pretty much everything that's in the Trust Flex. For the past probably 4+ years now, all the use case you find in Trust Flex is, I'd say it occupies easily more than 90% of the customer use cases we've done, right? So the Trust Flex datasheet is not under NDA. The Trust and Go datasheet is not under NDA, right? So if you already use those practices, if you leverage the Trust Flex use cases, you're going to be already in pretty good shape. The other thing and we want to keep the Trust Custom separate to make sure we dedicate our support to the right place. Trust Trust and Go datasheet is available, no NDA required. Trust Flex datasheet available, no NDA required. And Trust Custom, because it's custom job and resource intensive and all that, it will be under NDA, because we are the questions that are being asked to us becomes extremely confidential as we know the entire structure of the customer. For the device, you have to be able to guide the customer in the right direction to use the device correctly, because you could do wrong things with the device too, and we're not there. So for us, at the end of the day, it's support time. Hopefully that was a similar question that Nicola gave.
Yes. You gave a bit more elaboration, which is cool. Thank you.
All right, why don't we get back to Quinn's presentation and what Quinn was talking about. So Quinn, I think you were talking a little bit about the Microsoft Azure side of things. So
Right.
continue.
Let's get back to, I forgot what I was at before.
At the manifest, yeah. So we're
Right.
giving you we're giving a manifest out to the customer now, how Microsoft helps with your product offering, and how do you help the customer to scale. Yeah.
Yes, yes. So let's go through this device provisioning service together and see how we can incorporate the manifest information into that flow. Rachel, could you help me navigate through slide number 6? All right. So audience, what we are looking at right now is different players in the landscape of DPS. We have an IoT device that want to connect to the Azure cloud, in this case, the IoT hub, so that we can use the business logic to make informed decisions for the device to act on. And in this case, there's a device provisioning service that comes as a helper service. And this is how the flow go. First click, Rachel. So here's the device enroll information. What happened is after the device is manufactured, the device enrollment information is added to DPS. And this is the only manual step in this whole process. And what happened in this enrollment is we're going to enroll the device ID. We're going to enclose the device secret or the attestation mechanism like X509, TPM, or symmetric key. And so I think in this, if the manifest provide these informations, that need to be enrolled in the DPS, such that at some point afterward, Rachel, next click, which could be like a day or several months, when the device go online, it will go to DPS and ask, where's my home, which IoT hub I should connect to, and what is my configurations. Then what DPS does is it goes through, Rachel, the authentication process with the device, when in which it go and check in, is this device enrolled in my database before? If it's enrolled, then what is the device information that I need to match? And so it do the attestation and doing the handshake to prove the device identity. And when that happen, next click. The DPS, or device provisioning service, will then register that device into IoT Hub, at the same time populate the initial design device state to IoT Hub. And then next click, IoT Hub will return the connection info to DPS with next click. DPS will give the connection string to the device, so that now the device will, next click, directly connect to IoT Hub and establish the connections. When that happens, next click, it will then retrieve the initial configurations from IoT Hub that DPS was giving IoT Hub before. In this case, for like a smart mailbox, right? If the desired states when it first go online, you want the LED light to blink 3 times. Then IoT Hub will push that information to a device so that it gives a communications to the customer to know that the device is working or connecting properly or not. And when that's done, then next click, the device will start sending the telemetry to IoT Hub, which then consumed by the business logic in the back end. Next click. And the business logic will use the telemetry or the data from the device to produce the insight. Next click. And this insight will transform into a command to a device to operate more efficiently. And the telemetry and insight loop continue for the rest of the device life cycle. So this is the whole gist of what is device provisioning service do, and how manifest can plug into this this service.
The,
All right. Thank you for going through that with so much detail. It really helped clarify things for me.
I got a question for Quinn actually. So you've showed us how the DPS is architected within the Microsoft IoT environment. Can you give us the values that it brings? You know, when I first met you, I remember when our discussion, I literally saw the light. You showed me the light on what the DPS brings. You talked to me about how it can help scale globally and how it helps with the routing across different regions. Can you help to elaborate for the audience? I think we can benefit from that.
Yeah, of course, Xavier. So imagine that the manifest that you have is for one device, or either you use that in bulk, maybe. DPS have the feature that we can enroll the device individually, called individual enrollment, or we can enroll the device as a group. Depends on the device functions or features, or device authentication or attestation mechanism. So for example, the process or the demo that you go through with us before, where you produce the manifest and then you have to manually go to IoT Hub to get the connection stringed. If you do that for one device, that's fine. But in the long run, when you want to do it for 10 or millions of a device, it's become very time consuming. And so with DPS, I just go through, the only step that you need to do is somehow get the manifest information enroll into the DPS enrollment list. And after that, all the connection between the device and IoT Hub will become automatic. So that is one of the benefit is to provisioning or register the device to cloud as scaled. The other one is also do the load balancing, meaning in the way that it can help you to connect to one IoT Hub, or can help you to connect to multiple IoT Hub at the same time. And also, during that time, it can evenly distribute your device into different IoT Hub for a better communication, of more efficient communications. Does that answer your question so far, Xavier?
Yeah. Absolutely. Actually, it helps me to go back to the smart mailbox that you were talking about. You know, now here you go. You go back to your city of Phoenix, 5.5 million mailboxes connected, right? Now you can see all the bulk upload capability of certificates in the manifest into DPS can help scaling to that scale. And if you have the city of Paris or Taipei, now you have the routing advantage on all those countries to bulk upload those things all at the same time and scale globally.
Yeah, why don't we actually, to kind of recap, go through what somebody who is designing a smart mailbox, like what their steps are. So from the embedded side, you kind of just touched on this, but where would they start? They'd probably start with the development board? Or?
Yeah, so I mean, you start obviously developing with, starting with the development board that we've seen right here. So that's going to be, the giveaway is going to be the red board. The green board, you'll have to get it from microe.com. On the microchip.com, Microsoft TrustFlex page, you'll have all the list of hardware you need to duplicate. So you start with that. Use the Trust Platform Design Suite software to create that prototyped chain of certificates and get your project working. At least you get basic communication and you send MQTT message back and forth with Microsoft IoT Hub. You get that. So the next step, as you're getting to the development phase, you qualify and all that stuff. During that phase, that's when you're going to contact Microchip for the secret exchange when you use TrustFlex. It's not needed if you use Trust and Go because we provide the generic certificate right from the bat. Once you have the secret exchange completed, we basically ship you a few verification devices that will help you to close and validate those that configuration and those secrets are working during your development phase. Once you'll have a button on your e-commerce store that says, okay, validate, then we're ready to push in production. The only thing you do, you just buy devices. And as we buy devices, we provide you a manifest file that has the public credential on that. And to scale, obviously, that's when you start using the DPS service and the IoT Hub service from Microsoft, and then you move forward. I'm just talking about the security side of the project, not the rest.
Okay. Quinn, do you have anything else to add to that? So the manifest is then used at the IoT Hub. Do you want to add on to that what somebody would do?
Yes, of course. Rachel, you can bring up my slide that I prepared for the audience for the call for action, the last slide. Yes, so audience, I include a slide here for you to get started. When you get the manifest, what you can do is you can go to check out our Azure Device Service, which I have the link here, and I also include the sub-link of Quick Started to help you set up the DPS of the device so that the connection between becomes seamless, and also a link for the concept. As I promised earlier during the talk, there's also a link for Azure IoT Hub. Right here. And the last thing that I want to call for is if you need more information on anything that I did not get a chance to address today, I strongly encourage you to go to Azure Learning website. This is one of the link, and another link that I want to add on is the aka.ms/MS Learned IoT, and that will include different modules as well as lab that you can go through to start to visualize and planning for connecting your IoT device to IoT Hub through DPS. And so yes, thank you.
Oh, thank you. Thanks for showing us where to go. I think we have a final question maybe in the booth.
Yes, we do.
Yeah, we just have a couple of things that we're housekeeping here, but
Right. So survey link has just been dropped in the chats, so you guys can go to town on that. And while that's happening, I'm going to throw a softball to Xavier. Nuno asks, what are the physical protections for the ATECC 608A? Can it resist DFA and other side channel attacks?
So that is our IP. That's what our design team is working day in, day out. So I can't tell you, obviously, disclose that publicly. Even under NDA, we're not going to disclose this type of information. I can give you a high-level stuff. I mean, there's quite a few. They work. The way we work with third-party labs that test our devices, and they give us reports. And when they find something that needs to be improved, we obviously do a design upgrade of our device. So what do we protect against? What we have an active shield for physical anti-tampering at the die. There are various DPS, so differential power analysis protection. That's what you call side channel protection. Protects against, if you dummy the things down the way our architect presented to me once was actually pretty clever. You have 4 variables, which are the basics of electronics. You got current, voltage, frequency, so time, and temperature. And what attacks are trying to do is to act on those 4 variables, and we try to protect against those type of attacks. So what they try to do is to push the device into an undesirable state to, for example, push transistor into saturated zone and create unwanted behavior. So we try to build as much protection around it. Again, I couldn't give you the exact details, even if I was aware of exactly what they're doing. So we're protecting against those variances. And again, nothing is perfect. You got to keep in mind that no security is perfect. You got to be very clear, no matter if it's software or hardware. So it's a cat and mouse game for us. We learn from the lab, we implement. We learn from the lab, we implement. So yeah, we try to monitor those 4 variables as well as we can to protect against side channel attack, DPA, active physical tampering of the die.
cool. For me, I got like a couple of comments and a question. First comment is for Quinn, and it's from Armstrong. Armstrong says Azure IoT is a great platform for what he's working on. So that's an awesome, just kind of a thumbs up. Just wanted to share that with you.
Great, thanks, Armstrong.
Cool. Jared wants to know if you could, if just kind of a clarification, one device with a compromised key does not compromise other devices in a network, correct?
Do you want me to take this one?
Yeah, and it's actually kind of been answered. Nikolai is killing it today. So
what did he answer? And I'll compliment.
He says you're
as well when you don't answer, Xavier.
He says it's correct, but I think it's kind of a cool discussion point.
Yeah, so that's correct. If you use a public-private key infrastructure, PKI, right? We've seen the mistake, 2 mistakes being done, and they are trying to put that correctly. We've seen absurd thing. I was trying to find the right adverb, but there's nothing better than that. We've seen customers using the same private key for the entire fleet of IoT devices. We've seen that done. Don't do it. We've seen done customers using shared keys, so symmetric keys, and the same symmetric key for an IoT device into the entire fleet. Don't do this, because if that key is tampered, whether it's private or shared there, or symmetric or asymmetric, your entire fleet is corrupted. So there is a risk there. So good practices are, want to make sure it's not, it's said, you want to have, so if you use shared key, generally in the world of IoT, it's pretty hard to handle because of the logistics of it. But at least diversify your shared key at the bare minimum. If you use PKI with certificate authorities and stuff like that, you're already using a pretty good security practice, which is actually the most common one you want to use, because your private key is going to, your public-private key pair is going to be unique to each devices, and that's how you want to do it. So then you're obviously less at risk. If there is a risk of compromise, that will be somewhere else in the network, not necessarily on the certificate chain. And remember, your certificate, your keys are not everything in security. They are probably your most important foundation. You can attack the cloud platform and get other problems, right? So be careful of not using the same key everywhere.
And also on the device provisioning service side as well, we also, so one of our features is like we want the key being compromised, we can also revoke that device as well, especially if you do the X509 certificate, then we can revoke that leaf or that whole chain to make sure that the security is maintained within the rest of the device. Yeah, that's about it.
Okay. And let's see. I'll just drop this here. We're not really supposed to comment on future products, but someone mentioned student companion. I think was like, when are we going to do a PIC IoT with Azure support? So you technically can't answer that question, but I just thought it was an interesting comment.
What is the comment again? Sorry, I missed out on that.
So a PIC IoT board with that has a pre-provisioned ECC chip for Azure. So
I'll pick up that one. We've used our AVR and PIC platforms through several cloud platforms already, so we know how. I'm going to leave it there.
Yes.
I'm going to leave it there.
Stay tuned.
So contact us. If you really have a project in place that you're interested by that, just contact us directly and we'll plug our business unit in charge, which are actually Wayne, Rachel, are part of that team, and they'll help you with the project.
Perfect.
All right, I think that's a wrap. Thank you so much, Xavier. Thank you so much, Quinn. It's been great to have you on Skype. Love to hear your perspective. Really cool that we can have different people on this week, kind of share different perspectives and talk about things that we don't necessarily directly support, but definitely play a process in embedded design. So thank you, Quinn. Super grateful. And yeah. Just something. So tomorrow is Maker Day. We have 2 sessions, so double header live stream. So we have a live stream in the morning, we have a live stream in the afternoon. So in the morning, we're going to be talking to Web Things, Mozilla Web Things. It's kind of an alternative to a typical cloud provider, popular with makers, but I'm actually really excited for it because I was reading about it and it's really interesting. So give it a Google. And then in the afternoon, it'll be the Wizard of Make showing us how to make a BLE connected air quality monitor. And then Friday, we have our Low Power Sensor Networks Day with Kodo Technology, and we have partnered with Sensors Expo. So we have 2 tickets, 1 ticket to Sensors Expo and 1 ticket to Embedded Technologies Conference. So make sure that you join that day because that's kind of like our grand finale. And I think to wrap it up, I will read one of the haikus we got.
Yes.
IoT is great. Security is very hard. Microchip, please help. I hope this helped. So whoever wrote that haiku, nice. I hope you joined today. And Xavier also showed a bunch of different, there's a lot of videos, so lots of places that we're helping out with. So hope you guys, hope we answered that haiku plea for help. All right, thank you so much, and we'll see you tomorrow.
Thank you.
Thank you for having me here. Bye-bye.
Thank you.
Bye, Queen.